First up is Dave Moloney. Dave is an engineering leader with extensive experience in developing complex hardware systems at Google. For 15 years, Dave led the engineering teams responsible for the global sensors that capture the imagery for Google Maps and Google Earth. His leadership was crucial in designing, building, and deploying the sophisticated cameras, positioning, and LiDAR technology used worldwide. Within Google, the mapping division has been at the forefront of AI use. In June 2025, Dave joined the joint venture of Rivian and Volkswagen, where he will focus on developing next-generation software-defined vehicle platforms for EVs. This morning, Dave will focus on agriculture, though, and his title is Sowing Code, Reaping Intelligence, AI's Application in Agrifood. Dave Moloney. And do you could walk through it?
Yeah, or maybe I'll just do the...
Okay, because I got to switch stuff.
Right. First off, thank you so much, Jim and Jason, for inviting me to this event. Super exciting, my very first time ever in Hawaii. So, great opportunity to be here and see how beautiful it is. So, thank you so much for welcoming me, and amazing Pace Center as well. It's a really beautiful building. So, I wish I was a student here. It's a lovely place. So, I'm from Ireland originally, and
Get a little closer to the mic.
I started out actually in organic farming. I studied law and decided that was not for me, and became an organic farmer, working actually with the people beginning organic farming in the islands of Ireland and in the United Kingdom. So I worked with the two leaders actually, a year apprenticing with the Irish leader of the Irish Organic Farmers and Growers Association, followed by a year with somebody who was, I guess, the advisor for the Soil Association of the BBC on organic farming and advising farmers what to do at any given year. But ultimately, I went back to tech, became a computer scientist, working in coding and working on these kind of systems in the meantime. But I will tell you my personal kind of view, if you like, on AI right now is that I think I'm a big believer in permaculture and regenerative agriculture. And so I'm just exposing my bias right away. I'm going to lead into that. I also think that we don't really understand ourselves psychologically, so AI is a really interesting mirror for neuroscience. So that's kind of my other hobby, if you like, in AI. So these are the four topics I was hoping to cover, broadly speaking. Just an introduction, looking at, I'm going to look at some narrow aspects, particularly in the relationship of precision location and agriculture. I think it is one of the key unlocking technologies, and the ability to perceive three-dimensional space, which hopefully, for some of the younger engineers here, I hope they're inspiring tools you can play with and use. So, first opinionated statement, there's a huge amount of hidden cost presently in the externalities of agriculture. The carbon cost of preparing nitrogen fertilizers, the carbon cost of preparing various chemicals, and then the overuse of those, and then the massive effect of what it costs us both in human health and externalities to do with cleaning up water for the overuse of these nitrogen, phosphates, etc., and making a controlled water supply. So I'm slightly obsessed with water, and using too much is not a good idea. Maybe it's temporarily good for the bottom line of a public company, but it's not good for the planet overall. And I'm more interested in, I guess, something like the Long Now Foundation. Let's think about longer-term cycles for the Earth. If we want our children and grandchildren to enjoy the Earth. Second, what does it mean, to speak about this in terms of, what would regenerative agriculture benefit from? These are just some of the things that I think that, you can do with AI to have this long now perspective. And so, very targeted resource allocation, enhancing biodiversity. There's huge sections of even of Ireland where people are using set-aside now and creating massive diversity in birds, insects, etc., just by setting aside land. It seemed crazy a long time ago, but it doesn't seem so crazy now. But fundamentally, another source that I found super inspiring in recent years has been the Sheldrake book on fungi and mycelium. There's an extraordinary book. It's actually by Rupert Sheldrake, who's considered a very radical scientist. But the son of Rupert wrote this extraordinary book about the relationship between mycorrhizal fungi and the roots of trees and how plants speak to each other and help each other. And I think we haven't spent enough time looking at soil health. I know there's probably plenty of people, experts in the room, who know a lot more than I do. But the fact that plants speak to each other through these mycorrhizal fungi, and we have to care for the health of the mycorrhizal fungi, super important. And sensor technology, using AI, we can certainly help. This is essentially, people call it the wood wide web. Another observation I have, and I literally work about a kilometer away from one of the forefront humanoid robotic companies. It's a Norwegian company called X1 Technologies. And literally, as I'm driving to work in Palo Alto, I drive by their premises. So you have companies like Figure, X1, you have Elon Musk working on these things as well, a number of very interesting humanoid robotic companies. And I challenge you to think of this topic of, if each of us had a humanoid robot with a lot of dexterous skills, and you had the choice of saying to it, I want you to tend a garden to produce most of the food that I need for my family, at least the vegetarian food, would you do it? Would you have it walking the dog? Would you have it do the washing? It's going to work for you 24/7. So I know this may sound radical, but I guarantee you that within the next 5 years, you're going to walk into a Starbucks and somebody is going to have their robot with them. And you're going to have the same kind of dynamics of, is this an emotional support robot? I'm serious. You probably think I'm kidding, but we're right on the edge of it. And if you live in Silicon Valley, you see it. So I guess I've had the opportunity to kind of live in the future a little bit, working in Google in the last 15 years. I absolutely see it, that the economics of agriculture are going to shift when you have a dexterous, humanoid-like robot who can do stuff for you. It may seem like sci-fi, but it is definitely not, and it's happening. Look at the price of a robot for a unit tree from China, and tell me I'm wrong. And I kind of jokingly put in there that if you're a dairy farmer, and how you get up at 4 a.m. to milk your cows, sending the robot out and doing that this week might be a good option. Sorry, racing ahead here. I do think that you have to assume, even if you're directly, say, a farmer or an agriculturist, that everything adjacent to you is going to be empowered by AI, that you can't really ignore it. So you have to kind of assume the entire value chain ecosystem is currently being amplified in some way, shape, or form by AI. It's not something you can really ignore. And I've seen, for instance, one of my jobs in the past was setting up a large e-commerce selling Google hardware. What I saw was that at the time we were moving through a transition from retailers holding all their data and warehouses holding all their data and the makers of products holding all their data back, cards up. But what happened, in recent years, which made a huge difference in terms of the overall efficiency of producing hardware, is everybody put their cards down and they use companies like E2Open to share all of their data. So if I'm thinking about buying 1 million LCDs to make a new tablet, how many are you selling would be a pretty interesting information to know. Are you telling me the truth, Best Buy, or not? As to what's actually moving and the velocity of movement, so I could deliver you 1,000 a week as opposed to the 2,000 a week that you asked for, because you've actually given me transparency into your supply chain. And so AI applied to agriculture and commodity pricing is going to become huge. As a producer, you can't assume that you're working in isolation and being cards down so where you can see your data. I mean, if you own a farm or an agriculture facility today, I guarantee you that someone who's looking at it who is not you and making decisions about the future price of corn, future price of pineapples, whatever it is, they can see it anyway, as soon as they can, and that the insurer can see it. One of the biggest consumers of satellite data are insurance companies. So these are the 4 technology areas I thought I might kind of focus on and just delve into 2 of them in particular. So my advice to anybody who's involved in agriculture and see amazing companies like Greenwave out there providing amazing tools in the agriculture space. But it's the intersection of these 4 things, I think, that really make a difference to anybody involved in agriculture or aquaculture. Probably less mature in the agriculture space, but it can become something much more mature. So I'm going to delve into a couple of them. Today, and this is throw rotten tomatoes on me if you wish, but but I think in my personal experience in farming, there's a hell of a lot of intuition and who you spoke to at the market, your friends, a bit of internet kind of exploration, but not a lot of data-driven behavior. And coming from Google, which I know is a hyper, turn to 11 data-driven behavior company, you can easily, for your operation or for your tool being provided to a farmer, lean into data-driven decision-making. And you can move out of this intuition, tradition, training, data going out of, your techniques going out of date. And you can start to address some of these externalities that I spoke about as well that are currently being ignored. For me, water quality, air quality, in the last couple of years, I had the privilege to set up air quality sensors all across India. And I was just showing the other attendants here, windy.com, looking at the current PM air quality across northern India. They're burning the rice stubble as we speak, and there's a huge plume of PM, particulate matter that moves across northern India. So air quality, water quality, we can work with AI tools to significantly start addressing some of these externalities and start getting rid of some of the massive health costs associated with people with stunted growth and educational development issues, by starting to pay a bit more attention, as food producers to some of these externalities. Smith, etc., great. Consumerism, capitalism, great, but let's start paying a bit more attention to the externalities. Really, what data is all about is, there's just a simple comparison produced by an AI tool of, kind of traditional practices versus, suggesting for the future. But at the end of the day, the only reason you collect data is prediction. And so really all I think we're going to be talking about over this day is about how good and how well enabled are we going to make food producers to be able to predict. That's really what AI is all about. Could I possibly get, say a front bench in my farm of the best predictors that I could possibly wish for? Like the best pig person, the best wheat person, the very best, entomologist to tell me about the ball wheels eating my coffee, whatever it is. Could I literally have that on every farm? This perfect prediction bench of essentially genius level people. That is ridiculously possible right now because of LLMs. So, what do we mean, broadly speaking, on prediction? Here's a simple example of somebody who's, what typically affects tomato plants or tomato plants. But fundamentally, the farmer does not need to do this kind of work. Somebody, somewhere, is producing data sets. Fei-Fei Lin at Stanford, she was famously created ImageNet. She got millions and millions of images together and tagged them. So somebody went into a cat and a dog and a beach ball. And you end up with essentially tools that can look at just you or I taking your camera, your smartphone, and walking up to a plant or using a monitoring camera and taking a photograph of one leaf and saying, what is it? And how does it happen? Essentially, you take a photograph and then you end up with these sub-photographs being used by the AI tool. So you end up with a broad picture, okay, that's a leaf, it's got a problem with some dots on it. And then you end up with a number that indicates the likelihood that that is this particular leaf mold type. And that's the fundamental of visual recognition, is take a photograph of the thing, then take a smaller photograph, and then have a prediction of the percentage likelihood. This is all about statistics. Percentage likelihood that you have this problem. And so this is kind of what it looks like systemically, but bear in mind that the farmer just needs to worry about this, which is, I have a phone and I have ChatGPT access. I literally tried this. I took a photograph, I found a photograph of an infected tomato leaf. I put it into ChatGPT and said, what's wrong with this? And it immediately came back and said the exact correct thing, based on those previous photographs I showed you, in just ChatGPT. So every farmer who's currently on the internet with a smartphone with free access to ChatGPT has an immediate plant expert, and that is without even training. That's just raw ChatGPT. So all of this training, you can build products to do this. Have the most amazing pineapple growing expert system. You use this kind of technology, but then ultimately you're delivering this to the farmer. Take a photograph, feed it to my app. And by the way, most of the agricultural apps that I found on Play are horrendously privacy invasive. So I highly recommend you write your own and stop being harassed by privacy invading permissions on some of the farming apps. They're horrendous if you go look at them. And I used to work in Google Play, so. Okay, so precision robotics. I don't know if this will actually play, but one of my favorite movies is Interstellar. And those of you who watched it have probably seen the opening scene where these drone tractors basically start misbehaving. They all kind of cluster around the farm, so it looks like it probably won't play, but I think it's a great example of a view of the future. Look at Interstellar. And kind of get a sense of like, oh yeah, that's what it would be like to do autonomous farming with autonomous tractors. You just task them and they go up and do their thing. It's a pretty good representation of how that would work. So I think the key things, that as I think about future farming and current farming is think about remote sensing. That's where my expertise has been, is in putting air quality sensors autonomous across, say, India. Building systems that sit on cars that are used by total non-experts. The street view systems, you turn it on and you drive. It's that simple. You're playing Tetris, you're playing you're just driving along lines and changing the color of a road from red to blue. It's that simple. So you build incredibly simple sensor systems that are like deep scientific instruments that anybody can use. That's kind of your goal, I think, as a technologist, to build sensor systems. They're amazing instruments. They're amazingly well calibrated and they can be used in all sorts of circumstances: altitude, temperature, the amount of shaking it gets, you name it. Remote sensing, amazing opportunities for entrepreneurs in this space. High-speed sensing, I think there's several people going to be speaking, talking about driving down rows of apples or strawberries and looking in 3 dimensions at the strawberries or the fruit, and using LiDAR and camera images to figure out how to grab successfully a piece of fruit and pick it or look at it carefully. But precise positioning, I think, is incredibly important. Let's face it, most of these technologies came from the military. They were designed for dropping bombs in precise places, precise positioning, unfortunately, but they're great for farming too. So, talk about what you can in some of those things. Access to the cloud, very important. But I totally recognize, and one of the biggest things I've worked on in my career has been bringing the internet to every part of the globe. Starlink actually kind of began at Google. I was the product manager for the ground piece of that. Another person was working on the satellites. So we were trying to produce internet access for everywhere. You don't need to rely on Starlink. You can rely on LoRaNet and a whole bunch of other technologies today to light up your sensors, even if you're outside the normal coverage. So I think it's super important to think about internet coverage and offline use in any application you create that's AI powered. Can you collect data and then bring it to the net later on? Or can you take it online and put it in your phone so that it works offline? So there's lots of interesting techniques to bring AI to the farm, even if you have access to issues. So, very briefly on RTK, I don't know if you guys know what real-time kinematics is or come across it, but all of these tractors that drive around by themselves and do all their turns and whatnot, they're relying upon something from real-time kinematics. It's quite a big investment for a farmer, but bear in mind that most farms are open sky access to GPS. It's only in places like here in urbanizations where you have issues with inaccuracy on GPS. And a lot of, I think people who make systems for tractors like Garmin, they charge different levels for the level of precision that you can get from them. There are cheaper ways of doing that, but just bear in mind that during sunspot cycles, the 11-year cycles in the sun, they literally, John Deere told me to park their tractors one weekend this year because the RTK did not work. So, believe it or not, we go through a sunspot cycle that actually affects the accuracy of GPS, and we've got to be careful. So, there will be these moments, and if you look at GPS maps of Eastern Europe right now and Israel, you'll find that they're all turned off and messed with, especially places like Kaliningrad, the whole area, the GPS is all messed up. So if you're trying to plant wheat in Ukraine, good luck with a precision farming. So be careful using RTK in a war. Maybe I'll move on from there. Sorry, the fonts moved a little bit. I wanted to call out something about satellite, which is this little diagram over here. When you're purchasing satellite imagery of or taking it for free from Landsat, there's a thing called ground sample distance. It is literally that if you have an image that's say 100 by 50, how much land, almost like these carpet tiles, how much land is represented by one dot in the image? And so GSD is extremely important when it comes to getting imagery. I'll show you kind of what I mean in a second, which I'll move on in the interest of time. But I've read Mollison's permaculture books, and I want to point out that while I'm talking about very techie things, if you read into permaculture, you realize that they're looking at the three-dimensional shape of the land, the movement of water, and the whole 3D aspect of a farm. Not just one plant, but the entire movement of the land, reshaping the land a little bit for protection and keeping water. So when I talk about these topics to do with GNSS and images from the satellites, looking at the three-dimensional topography of your land, it really is, in my mind, coming back to how could I farm in sympathy with the earth and know exactly where things are. So companies like Pharmanaut, really interesting example of services companies out there that are helping with precision agriculture. I mean, you wouldn't believe. Are we out of time, Tim? Am I running over?
You have 3 minutes.
Gotcha. Thank you.
Sorry.
All of these areas, like variable rate seeding, are pretty extraordinary. You can literally have a tractor with a variable rate seeder drop, say, 10,000 seeds per hectare in this part of the field versus 25,000 seeds per hectare in other parts, because you literally created a map of your field. Perhaps like this one up here. This is using one soil. But literally, almost every day, one soil gets free imagery of your field. You can select your fields, and then you can start watching your fields over time. You can even do crazy stuff like, say, show my field yesterday and 14 days ago, and look at the two of them in 3D, and you're getting information about the quality of your irrigation, the quality of growth. And you can build, I guess you'd call it kind of posterized maps, which you then put into your variable rate seeder to say, put this amount of seed in these dark green spots, but do light seeding and much less water and much less fertilizer in these non-productive areas based on the history of this part of this particular field. We all know that plate tectonics, say Australia is moving about 2 inches a year, so if you seed at the start of the year and then you're sending in your other equipment later in the year, RTK even compensates for the fact that Australia has moved 2 inches since it planted. So it's pretty sophisticated technology. So I highly recommend looking at one soil. Very, very interesting product. So I'll just close. I didn't want to cover a lot of topics in great detail, but I just can maybe tee up because a lot of amazing speakers coming after me. But think of AI in these areas, like, if you're going to be specific and build a business, like what can you do either across several of these areas, or where would you even begin as a small farmer? My personal bent for a small farmer is begin here, irrigation. It's the easiest thing to get after. The other one is using tools like OneSoil. So it's low cost, very low capital input, very low per month input. Tackle irrigation. And you see people like MIT or PhD graduate students tackling irrigation for this exact reason. In developing nations, very low cost, smartphone driven stuff. As long as you have ubiquitous access, or you can create ubiquitous access, you're in great shape. So I'll leave you with this, that there are value stream opportunities right across the board. Personally, I'm inspired by the fact that if you take out the UN's SDG goals, these 17 goals, and start thinking about how can I create a business that lights up several of these in the context of food security. There's so many opportunities out there, and with the tools that we currently have with AI, with LLMs, you could literally build your own $100 million business that has extraordinary effects across these SDG goals. So that's where I would use. I'm inspired by the opportunity here, and I'd love to see some amazing businesses emerge in the intersection of these.